All right, folks, welcome back. So we have the next task at hand. We need to start to get the routes across the service provider cloud between routers 1 and 3 so that the Cisco sites can communicate with one another. So let's take a peek at the provider edge router 1. Let's show IP route VRF Cisco. We looked at this before and we saw that we're only learning about the connected route and nothing else, okay? So let's start small. Let's go over to Cisco's router 1 site. We have to do BGP peering between Cisco router 1 and service provider router 1. So all we've done is turn up the circuit and verify basic connectivity, okay? So let's go ahead and establish BGP with our service provider. So on Cisco side, show run section BGP, we can see that we don't have BGP running, okay? So we're going to turn BGP on. In this case, it's 65,000, okay? We're going to say neighbor 192.168.1.1 because that's the provider edge router, right? We know we can ping him. We've already verified all that. He's in remote AS 7029, okay? Now this is eBGP because we're going between two separate autonomous system numbers, all right? Since it's eBGP, we don't need to specify an update source. All we need to do is tell it where that neighbor is, okay? If we want to be fancy, we can do neighbor 192.168.1.1. We can activate him, which will turn on the IPv4 address family, all right? So now we can see it stuck that command under the address family IPv4. So let's go ahead and go under the address family, and let's go ahead and advertise a network to this service provider. Okay, so this is where the static route will essentially start to come out of the picture, and we'll use the protocols to effectively advertise routes and learn routes between our peers. We're going to go ahead and we're going to advertise the entire /22 that resides at site A. So we're going to say network 10.1.0.0, okay? And BGP wants the keyword mask. So we type the word mask and then we can say 255.255.252.0, okay? So what we've done is we've just taken every single 10.1.0.0/22 IP that we should either know about or have learned through the network, and we're going to dump those into BGP, okay? That's the idea behind the command anyway. So we'll see if that worked or not in a second here. So let's come over to the service provider, and you'll see that since he's running the VRFs, the commands, it gets a little bit more complex because the VRF's involved, all right? But it's the same exact concept, same commands. They're just kind of nested inside this VRF configuration, if you will. Okay, so we know we've already got the interface in the VRF, which is fine. Now we've got to do, that's the one I created on by mistake. That's funny. So when we go into BGP, all right, we're going to come in here, and what we need to do is we need to tell BGP about the Cisco site A. And there's essentially a VRF kind of command that you run for an address family. So what I mean by that is address family IPv4, but we're telling it for VRF Cisco, okay? So let's look at what that did in the config. So under BGP, it created a new address family, IPv4 address family for VRF Cisco. So essentially everything we need to do is going to be under this address family, okay? As far as the customer goes. So we're already in there. So we're going to say neighbor 192.168.1.2 is the Cisco IP. We're 1.1, okay? And we're going to say remote AS is 65,000, okay? So what we should see here, we should see some action here. BGP is not the fastest, okay? But what we see here is we see a neighbor come up for the VPN for VRF Cisco, okay? That's a great sign. So let's do show BGP VPN v4 unicast all summary, okay? So what we have here is we've got our peering to router 3, which is on the service provider side, but we've got a peering for 1.2, which is 65,000, which is our Cisco site. And look at that. We've just learned a prefix. So that's pretty cool. So let's look for show IP route VRF Cisco. Look at that. That's a wonderful sign. So we've got a BGP route for 10.1.0.0, and we can see that it's learned from our customer edge router. That's awesome. Okay. So what this route is that's the /22 that we put the network statement in on Cisco's router 1. So that's awesome. That's a fantastic sign. So that means that our BGP peering is working through the VRF, and now service provider router 1 is learning those routes just as we would expect them to. So let's go ahead and do the same thing on service provider router 3, all right? And site B router 1. So let's go to site B router 1. We've got no BGP config. So we're going to say router BGP 65,000, okay? We're going to say neighbor 192.168.2.1 in this case. He's remote AS 7029, and we'll be fancy and we'll activate him. Then we'll go into the address family for IPv4 and we'll say network 10.2.0.0 mask with the /22. Okay, so we've configured BGP, okay, for our service provider. We told it all the information, but it's never going to go up because we didn't configure the service provider side. So you can see it's never an idle. With any hope, once we do the service provider router 3, that will change, right? Show run section BGP. So you can see there's no VRF instance of an address family. We're going to go ahead and we're going to change that right now. So address family IPv4 for VRF Cisco, all right? In this case, we're going to neighbor with 192.168.2.2 in remote AS 65,000, okay? So we've got a console message that popped up, says that we've now got a neighbor, show, BGP, VPN, V4, easy for me to type, unicast, all, summary. Okay. So we can see we've got a neighbor, he's in 65,000, he's been up for 14 seconds, we've got no prefixes. So that's interesting, right? No prefixes. Let's just check the configuration on B router 1, show run section BGP. So there you have it. There's no the network statement 10.2.0.0.252. It's there. Okay, so let's just give router 3 a chance. So we've got an issue, right? Because we're not learning that prefix. So on router 1, right, as compared to router 3, we've got the BGP instance, and then we've got this address family for VRF Cisco, and we've got the neighbors defined, and they're activated, okay? However, we are not learning any routes on router 3 versus router 1. We're learning a prefix. So that's the task at hand that we need to figure out. Why are we not learning this route that like we are here? okay? So typically when you compare, let's compare the Cisco routers. Show run section BGP. Show run section BGP. So the other thing we can look at here, so if we go to show BGP neighbor 192.168 2.1 advertise routes. So we're not advertising any routes. We should be advertising routes because we told it about the network statement, but for whatever reason we're not, right? As compared to show IP BGP neighbor 192.168 1.1 advertise routes. Okay, this is what we want to see, but we want to see this on the site B as well. Okay, so it's a great command to kind of verify that you are advertising what you would expect to be advertising. Okay, show IP route, show IP route. Okay. So, do you guys remember? So this is a good example here. So when we built the sites, okay, and this is why I kind of purposely built the sites differently, because it changes the way the configurations are and it has a trickle effect, okay? So I didn't necessarily plan for this, but it just, I know what the issue is by seeing the routing table, okay? And it's cool to work through it together and kind of demonstrate this live. But anyway, going back to the way we configured Site A, the default gateways were all defined on switch 1, okay? So let me hop over there and I'll show you what I mean. Show IP interface brief. We can see VLAN 100, 200, 300, they're defined on the switch. However, in Site B, we decided to be different and configure the gateways on the router, making it router on a stick. So let's go to B router 1. Let's move him over here because he's site A. Excuse me, B router 1. When we show IP interface brief, we've got those interfaces defined here, okay? So that kind of changes the way BGP operates in a sense. What do I mean by that? So show run section BGP. When it's a connected route, so you've got, let me do this because it'll separate it. Show IP route connected, okay, versus show IP route connected. Okay, so router 1 has less connected routes than router 1 on the B side. Okay, it just so happens that all of the routes that we're trying to advertise from site B across the network, it happens to be that they're all connected routes because of the way we did router on a stick. So we've kind of created a little bit of a routing boundary, if you will. Okay, we need to get those connected routes into BGP, and in order to do that, we need to add a redistribution command under the BGP process. Okay, so if we come over to BGP and we say, I believe it's done here, redistribute, we're going to hit the question mark. So I've come under the address family IPv4, I've typed redistribute, and I've hit the question mark. You can see right out of the gate there is an option to redistribute connected routes. Okay, we can redistribute static, RIP, OSPF, essentially every protocol out there. We have the ability to redistribute, take those routes that are connected in my routing table and put them in the BGP table. Okay, so let's try to do that. Let's do that. Redistribute connected. Excuse me. There's a whole bunch of stuff you're going to learn about as far as metrics go, okay? I can hit enter here, or I can add a metric. All right. So let's just see what happens by doing redistribute connected. Okay. Let's just type that simple command. All right. Let's see if we have the advertised routes. Okay. So that looks a little better. All right. So I hit the up arrow to verify the advertised routes now from B side, and look at that, it changed to 6. So it's a bit different. So let's do a comparison again. So in this case, we're only advertising the /22, which is arguably a little cleaner, right? In this case, we're advertising individual /24s. So there's a drastic difference in the way we're advertising the routes. And you might ask yourself too, like, we typed the command for the /22, but the result of the advertisements was actually the individual /24s. And that's a result of the redistribute connected. BGP is only going to advertise routes that it already has in its table, okay, based on that network statement. So we can see when we had the network statement in there, it wasn't advertising anything. It's because we had to introduce redistribution instead. So BGP can get a little granular when it comes to that, but it's just the nature of the beast. It's the most complicated protocol out there, to be fair. So we can see, and this is where I want to tee up the next video, all right? So if we look at the tables in the table in site A versus the table in site B, they're getting more populated, but we don't see any BGP routes on either side, okay? So that's going to be our task for the next video. So there is, like I said, there was some more stuff I had made mention of that we need to do in the service provider side in order to get the routes that we currently have being advertised to this provider and the routes that we're advertising to this provider. We need to exchange those from a service provider perspective. And just one more thing, and then we'll end the video. So service provider 1, we make this a little smaller. Let's move this stuff back in the one window. Let's look at the routing table for service provider 1. Show IP route for VRF Cisco. So we see, right, and I know I've already demonstrated this, but 13 minutes ago we started learning about the 10100 routes coming from site A. If we look at service provider 3, show IP route VRF Cisco, when we looked at this before, we didn't see any routes, okay? I think I ran it up here, didn't I? I'm not sure if I did or not. I don't think I even bothered running it because we were never learning the prefixes. So obviously there's no point in looking at the table if you're not learning the prefixes. But at this point, so actually it's a good point. That's a good call. So we're learning 6 prefixes now, and when I do the route for VRF Cisco, we can see that, you know, we've got all the routes, okay, which is good. That's good. However, they're not being exchanged across the service provider cloud. So again, I know I'm kind of teeing this up. I'm probably beating it to death a little bit, but I'm trying to build a little bit of dramas for the next video. So what we're going to do in the next video is we're going to fix the exchange of those routes, and what we should get as a result is full connectivity end to end. So I will see you on that video.